Welcome students to the fourth lecture of Chapter 1 Software Engineering. In the previous lecture, we covered the software process models. In the software process model, we have seen that they are a specific way in which you are incorporating the generic framework features like communication, planning, modeling, deployment, coding, etc. So the way you are arranging these activities is modeling. Now we will see the evolutionary model first. The evolutionary model is nothing but a model which is evolving with time and experience. Generally, softwares evolve over a period of time. Requirements often change as development proceeds. We need to handle these changing requirements, and finally we end up with an unrealistic product in the tight deadlines in the market. Sometimes completion of software is impossible, but a limited version is introduced to meet the business needs. A set of core functional requirements are implemented and delivered beforehand, but new features are yet to be accommodated. A process model that incorporates such needs, such functional needs, and develop a project or a product that evolves over time are called evolutionary process models. Now, evolutionary process models are generally going to focus on the current requirements or current functionalities that the client desperately wants. So what are functional requirements? Functional requirements are those features or those functions that the user is searching for in the software that you are developing for him. Let us take an example of library management software. The library management software is having core features like search a book or issue a book or renting a book, okay, or paying a fine. So these are the various functions that a library management software should possess. Okay, now we will see the two different models of the evolutionary process model, that is prototyping and spiral model in detail. This is the prototyping model. The prototyping model is a model in which you are developing a toy implementation of the idea that the customer is giving you. Okay, so basically, before creating a prototype, there are what is the need of creating a prototype? Why we are going towards a prototype? There are two reasons. One reason comes from the customer side. The customer is they want product experience before development. They want to know what they are going to experience through the product that you are going to develop for them. If they are comfortable with it, they will give a go. Next is the customer has a general idea of the objectives of the software, but they do not know the detailed requirements or detailed functionalities that they want in the software. The second go comes from the developer. The developers are generally unsure of efficiency of algorithms that we are using, and they are unsure whether the OS will be able to adapt to that algorithm. So there is a question of technical feasibility. In order to address both these issues, the prototype becomes handy and comes to the rescue. Let us now see the prototyping paradigm. The prototyping paradigm in the diagram begins with communication. The users and the stakeholders meet to define overall objectives of the software. Stakeholders are those people who are directly impacted by the outcome of the project. They can be users, they can be an organization, they can be the team members, they can be the market. Okay? So users and stakeholders meet and they define the overall objectives of the software. Nextly, they identify what are the requirements that are known very clearly, and they are highlighting all the requirements which are not very clear and they still need more explanation or understanding. Okay, now based on whatever requirements are known, they are going to create a quick plan or a quick planning of what is to be done, and based on that they will create a quick model or a quick design model. So what happens in quick designing and quick planning is they focus on representing those aspects of the software that are visible to the user. They are giving visualization to the user in order to give him what? The product experience that he wants. So that he is getting here. Okay. Now after building this visualized thing, we are actually creating a prototype for the user. Now what is a prototype? Prototype is a toy implementation of the system. It is built using shortcuts. It may be inefficient, it may be inaccurate. You can keep in dummy features, and it is actually functionally low or not that reliable as compared to the final software product that you are going to deliver. But it can be a representation sort of for your software or for your product. Next is the deployment and the feedback phase. During this phase, the prototype is given to the stakeholders and the customer or the client. Then this deployed prototype is evaluated by them, and whatever feedback they give, that feedback is used to refine the requirements and build a new prototype if they are not satisfied. So this is an iterative cycle. It will keep on going until the customer is satisfied with whatever prototype is built and they give a go to the prototype that you have built. Until then, this is going to be a iterative cycle. So after you get a go from the customer over here, you can come out of this cycle, you can start your coding, you can start your testing, and you can start delivering your software and maintenance after that. So okay, this is what how it actually works for. Okay, next we will see what are the special advantages and disadvantages of the prototyping model. The prototype model actually is giving you an advantage in terms of active involvement of user. You can see in the deployment and feedback, the customer and stakeholders are asked for their valuable feedback and suggestions, whether they are happy with the experience they are getting from the product. So, unless and until they are not satisfied, they have to be involved in the project. Error detection is much faster. Of course, error detection will be faster because you are creating something called as a prototype. This prototype is nothing but a dummy representation of what your software will look like. So if there is any error in the prototype, you can finally correct it in the this building. Prototype has an additional cost. No problem, even if it has an additional cost, because paying that much is better than paying more for the project. So if you are paying an additional cost for the prototype, you are decreasing the overall cost of your project. Okay. Now, what are the disadvantages of the prototype model? First is it is a toy implementation. It is not the actual software. Therefore, there are chances that it will be inefficient and it will be inaccurate. The main reason behind it being inaccurate and inefficient is that the developers, they if they are not ready with some feature, or they don't have a technology, the latest technology, then whatever they are having, they are going to use that and bring out something. So maybe the product would have been better if they would have used the other technology which they did not possess. Okay, so it is suffering from these practical issues. Next is you are paying additional cost for the prototype. But what you are going to do finally, you are going to throw away the prototype, because what the client wants is a software. So you are paying the cost for the prototype, but you are throwing it away. Prototype is also named as a throwaway product. It will have limited functional capabilities. A prototype is something which is not as vast as your software that you are going to develop, not as vast as the product that you are going to deliver to the client. So these limited functional capabilities are going to give you a very short scoped view, or not a very large vision of how your software will look like. And you can say it is not reliable because you cannot depend on the prototype. It can never be a substitute for the software that you are developing. Next, we will move on to the spiral model. The spiral model is also an evolutionary model. It couples with the iterative prototype model as well as with the waterfall model. How that we will be seeing in a short period of time. The spiral model supports rapid development and it is very efficient at handling risks. Okay, now let us just focus on the diagram. The diagram says that this is a spiral model where it appears like a spiral with many loops. The number of loops is unfixed due to the flexibility of the spiral model. The number of loops can vary from project to project. You cannot say that if a particular project has 5 to 10 loops, all the remaining projects will be having the same number of loops. They can be either less or more. Each loop is called a phase of the software development lifecycle. Okay. So let us see how it works. Each loop, over each loop, one or more features of the product are elaborated and analyzed. The risks at the points are identified and they are resolved with the use of a prototype. Okay, so what is happening is over each loop here, you are identifying what are the requirements. Here you have a requirement plan. So you are sitting with the customer, you are finding out what are his requirements, you are gathering the requirements, you are moving forward. Moving forward, you are finding out what are the risks by building a prototype, showing it to the client. He will tell you whether he's satisfied with it or not. If he's not satisfied, again you have a requirement plan, you will have a second prototype, again you will find out whether he's satisfied or not, and the cycle will go on. So you are repeatedly defining your iterative prototype. Next is you are sitting with a customer, you are building a prototype, he is happy. You have resolved all the risks. You need to move on to the design phase, then code, then test, and then release. This is how it is going to actually work. Now let us see the phases of the spiral model. There are a total of 4 phases in the spiral model. The first phase is your you can say these are quadrants. So your first quadrant is having features of the product and objectives that are investigated. So what you are doing is You are planning your objectives and you are finding out, are there any alternative solutions? You are investigating, you are elaborating, and you are analyzing what you want from the software that you are developing. The second quadrant is a risk handling quadrant. Okay, it is resolving all the risks and alternative solutions are evaluated and the best solution is selected. Okay. The third quadrant is for developing and verifying the next level of the product. What will be your next level of product? When you are going to design, you are coding, you are testing, you are releasing. What will be your next level for the product? Okay, and this is the next phase. Means if you are providing the things in an iterative fashion, again in the next phase you are going to go through all this process. Okay, so your fourth quadrant is concerning the review and the results of the stages traversed so far with the customer and the planning with the next iteration. Okay, so this is how your whole spiral model is going to go. Now, how you are going to handle risks in the spiral model. The spiral model is providing you a scope to build prototype at not just one phase, but as many phases as you want, and hence it can handle risk very effectively because not just one, that till the customer is completely satisfied and you think there is no risk using this prototype and moving further, you can plan and build new prototypes continuously or iteratively. So that is how you can almost nullify or mitigate all the risks that are coming. Okay, so where can this spiral model be used? The spiral model can be used where you have large scale projects, because if you have a very large project, you won't be able to complete it in time within a deadline. So you need to focus on only that part that is desperately needed by the client currently. So a large scale project can be implemented using spiral model. Next is high risk project. As we already know, the project in which there are high chances of risk, it is better to eradicate or throw away a prototype, build new one, and take the cost of building prototypes rather than increasing the overall cost of your software. Whenever your requirements are complex, you need more planning, you need more risk analysis, and in order to minimize risk, you require more prototypes. So complex requirements, when you have for your projects, you move on to spiral model. If your requirements are unambiguous, you need to do this, because if you have ambiguous requirements, your spiral model will not be able to handle them properly. You need an expert team to handle risks, because building prototypes, finding out risks, all these things come with experience. And with experience, you get an expert team. Okay. So what are the advantages of the spiral model? The spiral model is a series of evolutionary releases. We already have seen plan the next phase. Okay. It subsumes all models. How does it subsume all model? Because in a single loop, if you follow this single loop till here to here, what you are doing, you are following the waterfall model. You are planning requirements, you are requirement gathering, you have objectives, you have analysis, you are doing design code, test, release, and finally you are moving on to the next phase or the next feature. Secondly, you are using something called as a prototype. So you are using the previous prototype model. And thirdly, you are developing your software in iterations. So it is an evolutionary software. So your spiral model is covering waterfall, prototype, as well as evolutionary model in itself. It is very good at risk handling because we are using prototypes. Disadvantage of this model is it is a very complex model. So it is difficult to understand the spiral model during development phase. It requires a very knowledgeable staff because it is best for risk handling. Okay, it is not fit for outsourced projects because you cannot trust the company where you are outsourcing your products. Okay, they may not be able to efficiently handle it, and it is expensive. Expensive because you are creating a prototype, you are discarding it, creating again, discarding it. You require an expert team, so you need to have cost for it. Then you are having coding cost, testing cost. So overall, your total cost for developing the software can increase. So it is an expensive model. Okay, so that's all for today. The remaining models we will see in the next lecture. Thank you.